So today we're doing section 2, and we're going to be covering polynomial division. So as we get started today, I'm going to start with this first example. In this first example, I want you to notice that it's going to be different than most of the problems that you do, but I want to make sure that we review it because we're dividing by 2x. 2x is it's a monomial. Right? Monomial meaning one term. So when we divide by one term, it's pretty straightforward. So I could rewrite this as a fraction. So it would be 8x to the third plus 4x to the second minus 10x minus 3, and then put that all over 2x. Do you guys agree those are the same? Right? A fraction bar is division. Okay, and then what I can do is, since I'm dividing by a monomial, a single term, oftentimes breaking it up into several fractions is easier. So I'll write this as 8x to the third over 2x plus 4x to the second over 2x minus 10x over 2x subtract 3 over 2x. Are we clear with that? Yeah. Okay, and then 8x to the third divided by 2x. I'm just going to reduce the fraction here. And so you can see 8 divided by 2 is 4. And then x cubed divided by x is x squared. And then the next one, right, the 4x squared divided by 2x. Well, 4 divided by 2 is 2. And then x squared divided by x is x. And then subtract. Now we're going to do the 10x over the 2x. 10 divided by 2 is 5. You can see the x divided by x is just 1, so we're just left with minus 5 here. And I'm going to leave this as 3 divided by 2x here, and that will be the answer. So, and I just want to put a little note in our notes here. So 3 over 2x, okay, is not the same as 3 halves x. Right? You can't just bring the x that's in the bottom to the side. Whereas if it's in the top, if it was 3x over 2, then 3x over 2 is the same as 3 halves x. Okay? So just keep that in mind. And that'll be the first example. Okay, so when you're dividing by a monomial, it's easier to turn the division into a fraction, and then you can break the fraction into parts and then reduce the parts. Clear? Okay. Well, let's come down here, and I want to up here. And I want to review elementary school division, right? Division of a base 10 number. And then I want to show you how to do it with a polynomial, right? I have a polynomial that's right here next door. And then I just want to show you how cool it is. Okay, so let's go here. If you remember correctly, when we do division, right, usually we're going to ask the question, right? Usually you take the divisor, right? 13. and we will ask how many times does it go into 1, right, which it doesn't go into 1. So then you would say, well, how many times does it go into 15, right? How many times does 13 go into 15? One time, and you would write that usually above the 5, right? And then you would multiply that times the 1 and the 3, right? Usually we just say 1 times 13, but we are multiplying it by both, and so 1 times 3 is 3, 1 times 1 is 1. What would you do next? Good, we're going to subtract. And you can see here, 5 minus 3 is 2, 1 minus 1 is 0. Okay, and do you guys remember, normally we bring down the next term. And when we repeat the process, we'll ask, what do you multiply 13 by to get 27? Or how many times does 13 go into 27? Usually is what we ask. How many times 13 go into 27? 2 times, right? I'll write that above the 7 there. 2 times 3 is 6. 2 times 1 is 2. Then I'm going to subtract those. So 7 minus 6 is 1. 2 minus 2 is 0. And then I bring down that one more term. And then 13 goes into 13 how many times? Right? Now I'm repeating the process again, right? 13 goes into 13 how many times? 1 time. 1 times 13 is 13, right? 1 times 3, 1 times 1. And then I'm going to subtract. I get 0. Okay, and if you remember correctly, this 0 here is the remainder, right? There is no remainder this time. 13 goes into 1,573 evenly, is what we'll say. How are we doing? Are we good? Okay. Well, now what we need to do is we need to do it with a polynomial, right? Where we have this, right? X cubed plus 5x squared plus 7x plus 3 divided by x plus 3. Are we together? Did I really print a whole blank page? That's a gift. I just wanted you to have it. I printed an extra blank page to your notes. Okay, with that said, let's look a little bit more closely here. Now, this is how we're going to start. I'm going to ask, what do you multiply x by to get x cubed? What do you multiply x by to get x cubed? Okay, we definitely have to multiply it by x, right? But x times x is x squared. So I need something more than x squared. If I multiply by x squared, right, the x squared, right, times the x squared is x cubed, right? And then the x squared times the 3 is 3x squared. Remember, I have to multiply it. You have to distribute it through the x plus 3. Isn't that what I did over here, by the way? Whoops. Didn't I take the 1 and multiply it by the 3 and then by the 1? Right? So I went to the first one first and then the second one, but I could do it the other way around. So okay, it's the same there. What was the next step that we did? Subtract, okay? Now I'm going to be really obnoxious. Instead of saying subtract, I'm going to say draw your line and change all signs, because I want to make sure I distribute the subtraction through. It has to affect both terms. So now I'm just going to add going down instead of subtract, but I really am subtracting because I distributed the negative. Got it? And so adding going down, 5x squared plus the negative 3x is 2x squared. And notice that the first terms cancel out. Now, I'm not going to put that into our notes as canceled out. I'll just do it with my little highlighter here. Those terms always cancel out. Okay, and then if you remember correctly, we brought the next term down. Okay, at this point, we're repeating the process. We're going to ask, what do you multiply the x by to get the 2x squared? Okay, and is that a positive or a negative 2x? Positive 2x, all right, plus 2x. Now, the reality is I'm going to multiply the 2x times the x and then the 2x times the 3, right? But notice how my arrows are going to start getting really cluttered, right? So I'm going to stop drawing the arrows in after the first one, but know that we're still distributing through. So the 2x times the x is 2x squared, and then I do the 2x times the plus 3 right here, and that gives me 6x, and it's plus 6x. Are we okay with that? Okay. Now we're going to subtract. Draw your line and change all signs. So by changing all signs, I can add now going down instead of subtract. And so 7x plus negative 6x is x. And you can see that the first ones are just going to cancel out and give me 0. I still have a term to bring down, so I'll do that. What do you multiply the x that is here now? We're repeating the process by to get the x down here. Yeah, 1. Is that a positive 1 or a negative 1? So I'll write plus 1. And then I'm going to distribute that through, right? 1 times x is just x. And then 1 times the 3 is 3. Then I'm going to subtract. Draw my line and change all signs. And notice that they actually both cancel out. I'll just write 0 here. And you can see that this is my remainder. Okay, now I want to get to this third column because this is kind of cool. I want you to note the relationship between the division of base 10 numbers and polynomial division. Okay, so notice here, so I want you to see the relationship between what we did here and what we did here. Okay, they're actually super closely tied. So notice here, I say if x equals 10, then we're looking at the polynomial division here, notice the x plus 3 is the divisor. So if I put the 10 into the x here, I get 10 plus 3. What's 10 plus 3? 13. Okay, so the x plus 3 here is 13, right? And this is 13, right? If x is 10, then that x plus 3 is 13. Notice that they relate really nicely there. Do you see it? Okay, so we see a relationship between these two. Okay, and let's take a look now at the next part. X cubed plus 5x squared plus 7x plus 3. That's the dividend. That's what's underneath. If x equals 10, notice what happens here. This becomes 10 cubed plus 5 times 10 squared plus 7 times 10 plus 3. Well, 10 cubed, isn't that just 1,000? 10 squared is 100 times 5, isn't that 500? 7 times 10 is 70 plus 3. Okay, and isn't that 1,573? You see that? So notice, right, that the dividend, when I put 10 in for x here, that these match. You guys see that? So now we have this relationship, right? The divisors when x is 10 match. The dividends when x is 10 match, right? But notice that we don't stop there. The answer, right? Wasn't the answer of our polynomial division x squared plus 2x plus 1. What does that equal when we put 10 in? Well, it's 10 squared plus 2 times 10 plus 1. That's 100 plus 20 plus 1, or 121. So notice that this, right, the quotient when x equals 10 is the same as the answer here. Isn't that cool? Okay, so notice, okay, notice that I actually picked a polynomial where you can see this relationship really clearly. It doesn't always, you don't always see this relationship this clearly, but notice here, right? This is 1, 3, right? And then do you see a 1 and a 3 here? See that? Notice, right? 1, 2, 1. This is 1, 2, 1. Okay. This is 1, 5, 7, 3. This is 1, 5, 7, 3. Okay, are we good? Notice 1, 3, 1, 3, right? And it's subtracted, and you can see the subtraction there and there. 2, 7, 2, 7, 2, 6, 2, 6, 1, 3, 1, 3, 1, 3, 1, 3, 0, 0. Right? The numbers matched all the way down. Isn't that super cool? So what you were doing in elementary school was just a more focused form of polynomial division, right? And so, and the reality is I could also do this with multiplication. We just didn't have the time. So I chose division because division's super cool. Again, I had to pick a polynomial where you could visually see it, right? Because not all polynomials will work that way, but this one does. So, okay, are we good with this? Can we keep moving? Okay, so then you'll see here the next part. You can see, oh, hang on. The three expressions represent the same algebraic operation. So, and I just want to point this out, right? So having, right, this is the one that we just did right above, right? This is the division, using the division symbol, right? Then the next one, right, that's using that division bar, right? And then this one's using the fraction bar. But all three of these are the same. Are we good? Okay, so like on your homework tonight, I can write it any of those three ways. And my expectation is that you'll do it like I have it up there. Okay, now, here's the thing that we need to come into. There's two types of problems that now need to be addressed. One is, what do you do if you have missing terms? Okay, and then the other one is, what do you do if you have a remainder? Got it? So what do we do when we have missing terms? Let's focus on that one first. I'm going to put a note in here. And I'll just say you always account. So you're going to always account for missing terms. In the numerator and denominator. Okay. So let's take a look here. Example 2. What's the highest degree in example 2? Okay. The 2x to the third is the leading term. What's its degree? 3. So you start with the highest one that you see, and you make sure that every power is represented underneath it. So is there a quadratic term? So we have 3, a cubic term, right? 3. So is there a quadratic term? Meaning is there a term in the numerator that has a square on it? Yep. So that's not missing. Is there a linear term? Is there a term that's to the first power in the numerator in the top? And you can see, no, it's missing, isn't it? It's missing, I'll call it the x term. Okay, and then so that's the first, right? So then you keep counting down because you have to look, there could be more than one missing term. So we have 3, 2, 1's missing, 0. Is there a 0 term? Yeah, that's the constant. Okay, so you have to have all the terms from whatever the highest power is, which in this case was 3, all the way down to 0. Is that clear? How about in the bottom? What's the highest power in the denominator? What's the highest power? Good. It's a 1, right? Okay, and then you just count down 0. Is there a term that has a 0 power? Yeah, it's the constant, minus 2. Okay, so what I'm going to do now is I'm going to write my division symbol here. And I'm going to rewrite the 2x to the third minus 4x to the second. And then I'm going to put in a 0x here and plus 2. And then in the denominator, we're going to do 2x minus 2. Okay. And then we're going to do all the work that we did up above. So I will ask the question, what do you multiply 2x by to get 2x cubed? What do you multiply 2x by to get 2x cubed? X squared. So I'll write that here above the x cubed. And I'm going to distribute it through the 2x minus 2. So x squared times 2x is 2x cubed. And then x squared times the minus 2 is minus 2x squared. Now I'm going to subtract. Draw my lines and change all signs. And when I add going down now, I get negative 2x squared here, and the first terms cancel out, which it should always cancel out. And we're going to bring down the next term. Now, notice I'm bringing down the placeholder. Okay, by bringing down the placeholder, it makes everything line up really nicely. Okay, and I'm going to repeat the process. What do you multiply 2x by to get minus 2x squared? What do you multiply 2x by to get negative 2x squared? Negative 1x. Now I am going to distribute it through, but I'm not going to draw the arrows. So the minus 2x times the 2x gives me minus 2x squared. And then we're going to do the minus 1x times the minus 2, which gives me plus 2x. Going to draw my line and change all signs. And then when I add going down, I get negative 2x here. Okay, and then I'm going to bring down a term and repeat the process again. What do you multiply the 2x by, right over here, to get negative 2x down here? Negative 1. I'm going to distribute that through. -1 times 2x is -2x. And then -1 times the -2 is +2. Going to subtract, draw my line, and change all signs. And then that gives me a remainder of 0. And so my answer is x squared minus x minus 1. Do I need to have the 1x? Can I just write that as minus x? And the answer is yes. Example with a remainder. Now we need to know what do we do when there is a remainder, when there is something left over. So let's take a look at this one. Okay, so whenever we do division, we have to look for missing terms. So in the divisor, in the dividend, that's the first one. What's the degree of this dividend here? Oops. Okay, good. It is 2. So then, is there a term to the first power? Yep. Is there a term to the 0 power? Yep, it's this 12. Okay, and then, so there's no missing terms in the dividend. What about the divisor, the second one? What's the highest power? 1. And then you just count down, is there a term to the 0 power? Yep, so does this have missing terms? Right? I'll write over here, no missing terms, just so that it reminds you that we looked. Because you should always look for missing terms. And I'm going to do my division here. So the x plus 3 here, the x squared plus 6x plus 12 there. Okay, and then I'm going to start the process, right? What do you multiply x by to get x squared? X. So then you're going to distribute that through. So x times x is x squared. X times plus 3 is plus 3x. Now you're going to draw your line and change all signs. And you can see that you're going to get 3x here, bring down a term, and then it's repeat the process. What do you multiply the x by here to end up with 3x here? Huh? Plus 3? So 3, right, times the x, 3 times the 3, so 3 times the x is 3x, 3 times the 3 is 9. Now I'm going to subtract, draw my line, and change all signs. That leaves me here with a 3. That's my remainder. The reality is that 3 still has to be divided by the x plus 3, doesn't it? Do you guys recall that? Here. So I'm going to add here a fraction. Okay, and the 3 that's here still needs to be, I'll pull the x plus 3 from here. It still needs to be divided by the x plus 3. By the way, isn't that what we did in elementary school? I should have probably did this first. But think about it, right? If you had 5 going into 37, right? No, let's not do 37. Let's do 34, right? How many times does 5 go into 34? 6 times, right? That gives you 30. Subtract those, you're left over with 4. So didn't we write that as 4 divided by 5? Didn't the 4 still have to be divided by 5? When we write it 6 4/5? right? And 6 4/5, isn't that a fancy way of just writing 6 plus 4/5? Do you see that? So what we're doing with polynomial division, writing the remainder the way that we do, isn't that how we always wrote it? So, and I just like thinking of it in terms of the remainder 3 still has to be divided by the x plus 3, which is why we write 3 over x plus 3. Get the idea? Okay. Is this hard? It's going to be tedious, right? But it's actually not hard. So let's do one more. Okay, and I believe this is the last one, right? And the reason I chose this one is this time the divisor, what you're dividing by, is not a binomial, it's a trinomial. Let's see here. If you look, like if I go back up here, right? Right, this is dividing by a binomial here. So once you're getting to 2 terms or larger, you're going to do long division, and the steps are no different. It's like, I don't even want to teach it, but I think you need to see an example just so that you can see that it is no different. So I'm going to draw my division symbol here. I'm going to look for missing terms. What's the highest power in the dividend? 3. Is there a term to the second power? Yep. Is there a term to the first power? Yep. Is there a term to the 0 power? Yep. So there's no missing terms in the dividend. What about in the divisor? Highest power is 2, 1, 0. No missing terms in the dividend or the divisor. So I can go ahead and write here x squared plus 3x minus 1. And we're going to see how many times it goes into 5x cubed plus 14x squared minus 7x plus 4. Now watch. What do you multiply the leading term here, x squared by, to get the leading term here? 5x cubed. What do you multiply x squared by to get 5x cubed? 5x. Okay, good. Now we're going to distribute that through. It has to go to all 3 terms. So 5x times x squared is 5x cubed. 5x times plus 3x is plus 15x squared, and then 5x times minus 1 is minus 5x. Are we good there? Okay. Then I'm going to draw my line, okay, and change all signs. Notice that the first term, right, it should always cancel out. It does. Okay, and then we have the 14x squared and the minus 15x squared, which gives me minus x squared. The minus 7x plus 5x is minus 2x. Okay, and now we're going to bring down a term, the plus 4, and continue on. We're going to repeat the process again. So what do you multiply the x squared by to get the minus 2x squared here? What do you multiply x squared by to get negative x squared? Negative 1. Okay, and I am going to distribute that through all 3 terms. So negative 1 times x squared is negative x squared. Negative 1 times minus 3 is minus 3x. Okay, and then the minus 1 times the minus 1 is plus 1. I'm going to draw my line and change all 3 signs. Add going down, I get 3 here. I get x plus 3. And then the x squareds cancel out. So notice that my remainder now is x plus 3. It's a binomial. Okay, but it's not going to change at all. So I'm going to add a fraction here. And in the top of the fraction, I'm going to write the x plus 3. And in the bottom, I'm going to write the divisor, which is the x squared plus 3x minus 1. And that will be the answer. Okay. Does it feel like it's the same thing again? Right? So it shouldn't freak you out. I think you have a couple on your homework tonight. So just make sure you look for missing terms. Make sure you know how to work with the remainder. Are there any questions? Okay, with that, we'll wrap up our lesson.